All right, welcome back, kids. Today we're going to examine more closely arithmetic series. For instance, I'll just remind you the difference of sequence and series. This is the explicit arithmetic sequence formula in which your first term starts at 5 and you constantly add 3. That's what that means. And you could have put a 1 in here. 1 minus 1 is 0. 0 times 3 is 0. And you evaluate that your first term is 5, and you can create a list. By putting a 2 in here, you essentially add a group of 3 to 5. By putting a 3 in here, you add 2 groups of 3 to 5, and so on and so forth. And with this, I could easily calculate, let's say, the 10th term or the 100th term. This is a list, or what we call a sequence. From the same expression, we could take that list of terms and add them together. And that would look like this. Starting, let's say, at the first term and stopping at the 4th term. Again, your first term, now we're just putting the whole numbers 1, 2, 3, 4 in for n. The first term is 5, next one is 8, 11, and 14. What's unique about arithmetic series is that the sum of your first and last term, which happens to be 19, is the same as the second term and the second to last term, which is also 19. So this happens to be 2 groups of 19. So this pattern we're gonna examine more closely. Because from that same situation, I could add up 100 values. Again, I chose this expression because it's easy to see that your first term is 5 and you're adding 3. And then what this means is we're going to find the sum of the first 100 terms. So we could start writing it like such, pardon me there, and add them up in this order. 5 and 8 is 13, 13 and 11 is 24, so on and so forth. I'm gonna skip 95 or so terms, and I'm actually going to jump to the 100th term. So thinking about the 100th term, I'm gonna pretend there's a 100 there. 100 minus 1 is 99. 99 times 3 is 297. 297 plus 5 is 302. The last term of this sequence is 302. To figure out the previous term that would come before that, I could do it one of 2 ways. Since we're adding 3 each time, I could just subtract 3 and get 299, or I could actually substitute a 99 into this. Either way, we're going to get 299. So now we're going to think about something that we thought about last year. And again, not that all these sums add up to 19 like the last time, but the sum of the first term and the last term, which happens to be 307, and the sum of this second term and second to last term happens to be also 307. We're now going to just think, I don't want to write all these out, but we're going to think to ourselves, what would be added to 11? Clearly, something that would add it up to 307. Now some of you are like, oh, that's easy. Take 307 and multiply it by 100. Well, that's not true either. As you get closer and closer to the middle here, you're going to run out of terms. Actually, the 50th term, whatever that value is, will be added to the 51st term. They again will add up to 301. So we really need to think about not how many terms we have on this list, but how many pairs of terms. and the number of pairs we have is equal to half of the total. We have 100 things, we have 50 pairs. So this list would have 50 things on it. So the expression is going to be 50 times 307. I think I will just do this. It's 15,350 in this instance. So here's a common problem you might encounter on today's assignment. They ask you for the sum of the first 10 things from a list that happens to be arithmetic. I'll do 7m minus 2. Now at first you might not be sure that this is arithmetic, but substituting a 1 in here, you get 7 minus 2 is 5. Putting a 2 in here, you get 14 minus 2 is 12. It has a potential to be arithmetic. Putting a 3 in there, you get 21 minus 2 is 19. And now we do see that, in fact, this is could be written explicitly as starting with 5 and adding 7 each time. And now I'm going to just jump to the 10th term. 10th is where we end. 10th term is 70 minus 2, which is 68. So it turns out that since the sum of the first and last is 73, they're all going to add up to 73, each pair. 12, some number, 19 with some number. Again, if you have 10 things on your list, how many pairs will you have? You'll have half that. Half of them will be able to pair up with the other half. So we take 10 and divide by 2. Five times 73 is 365. This is the argument for why we should have 5 long months, each with 73 days in it. Works out a little nicer. All right, let's try another one. Because some of you might be saying to yourself, what if I have an odd number? Then they won't pair off. In other words, your first term and your last term pair off, your second term and your second to last term pair off, and you have all these pairs, but what if you have this guy which has no pair? Essentially, in this instance, we see that we have 1, 2, 3, 4 whole pairs, and this makes a half a pair. The list would have had 9 things on it. It would have had 9 things on it, and 9 divided by 2 makes 4.5 complete pairs. The formula still works, so now we're going to talk more generically about this formula, how this formula works. It says this, if you wanted to find the sum of the first 100 things from a list that happens to be arithmetic. I'll just call that some sequence that is arithmetic. And what that means is that you're going to take your first term, add it to your second term, add it to your third term, and stop when you get to your last term, which is 100, the 100th term, a sub 100. You add your first and last together and get a sum, and in this case, it is the first term and the so-called last term. It's the 100th term in this instance. And how many things do we have on our list? 100, so we divide that by 2. And that expression gives me essentially 50 pairs of the sum from the first and last term. So even more generically, we write it like this. To find a sum of n items. Now we have to think to ourselves, there's n things on this list. Again, you're starting with the first thing. You add the second thing. You stop when you get to the last thing, and in this case, the last thing is the nth term. Same technique. The sum of the first and the last term could be expressed like this, the sum of the first and last term. The number of pairs we have on this list are half of the total things on the list. The total things is n, so we have half of that. That's where this expression comes from. So you'll see this. The sum of n things could be rewritten as n divided by 2 times the quantity a sub 1 times a sub n. Specifically, I just want you to think to yourself like this. This is the first thing, which is easy. You put a 1 into your equation. And this is the last one. I can't tell you what number you're going to use because it depends. If you're finding the sum of 45 things, you put a 45 there. So we're going to try one more. Let's say I want to sum from the arithmetic equation 2n of the first 45 things. It's good to start. Put a 1 in there, you get 2. Put a 2 in there, you get 4. Put a 3 in there. I'm just putting the numbers 1, 2, 3, 4 in there. When I put a 3 in there, I get 6. When I put a 4 in there, I get 8, etc., etc., etc. What is the last number on my list? It's the 45th term. In this case, it's 90. So now applying this formula that says if I want the sum of the first n things, I take n divided by 2 times the quantity, the first term and the last term. In this case, specifically, we're adding 45 things. So we use 45 divided by 2. The math will still work out, even though there's a fraction there. Your first term is 2, and in this case, 90 is your last term. I'll just rewrite this one time as 45 over 2 times 92. Now I'll do the math for us. And you get 2025. All right, that's how it goes. Again, let me know if you have any questions. So this is me saying, do you have any questions?